Good morning, everyone. I'm representing Wilson Transformers. I've been with Wilson Transformers since 2000. We basically manufacture transformers. We've got two factories, one in Wodonga and one here in Glen Waverley. In Wodonga, we've got about 150 employees, and in Glen Waverley, it's about 350. So we've got about 500 employees altogether. And ever since we started from 2000 up to 2018, we are the biggest manufacturers of transformer in Australia. So let's go ahead with that. It's a family business. We are into the third generation of the family at the helm. They started in 1933. Now it's a local company with global footprint. You can see we've got offices and sales and support almost all across the world. We've got in US, in Europe, and obviously all the manufacturing is here in Glen Waverley and in Wodonga. As the name says, the transformer people, we offer complete solutions to transformer, right from the initial design up to erection, commissioning, servicing, and disposal as well. So that's a snapshot of what we do. As the pictures will tell, all across, there are distribution transformers, there are power transformers, and the other sort of services which are required in testing and maintenance and monitoring as well. Now, we started with Creo in 2000, late 2000. Prior to that, the snapshot in June 2000 was, as a CAD package, we were using AutoCAD, which was basically 2D drafting because the views didn't talk to each other, so it was a lot of manual stuff there. And we had some amount of automation using AutoLisp. And the drawings, the output to the manufacturing were big A1 size sheets, maybe 4 or 5. All the data was there, detail was there. If you had to revise something, you had to revise the whole drawing. It was very clunky, and managing was quite difficult. The bill of material was not automated, it was manual in Word. So obviously human error used to creep in. Design calculation was basically Microsoft Excel. We still use it, but a lot of it is automated and brought to other programs as well. And for manufacture, some amount of the manufacture was suit on job. So if we had multi-unit jobs, and say for pipes, as you would see in the pictures which I'll show you, if you had multi-unit jobs, the pipe from one unit wouldn't fit on the other because it was suit on job, so it wasn't exactly accurate. Now we started the Pro implementation late in 2000. Currently we have 18 licenses of Creo, and 1 license of Mechanica, structural simulation. We have a team of about 16 mechanical engineers. Apart from that, we've got 4 electrical, and we've got 4 control guys as well. And what we looked for when we brought Creo was greater flexibility to cater to customer requirements. Now, our major competitors in Australia were ABB, Alstom, Siemens, all the big players. So, we sort of, at that point of time, we were trying to get orders, and the conversion of tenders into orders was basically on our flexibility. What others couldn't do, we did it. So that's why. So when we started doing this, we wanted to build up a structure, a system which was very, very flexible, so we could cater to complex designs and accuracy. So we were able to handle complex designs. There was design data and validation, and data robustness. So prior to Creo, we had tried out for a couple of years other 3D packages, but nothing worked out until we brought Creo. And then there was data robustness, right? As I'll say, we work on a structure bottom up. So, parts come together, assemblies grow together, and we get the final structure. So we tried to replicate anything which was happening on the shop floor. So in the process, any problems which might occur on the shop, we preempted them. We saw them, we looked at them at the design stage itself and sorted them out. And obviously, we achieved shorter design and manufacturing cycle time. Now, as I said, initially there were a couple of big A1 size sheets. So here, from 3 or 4 big sheets, we came down to A4 size, maybe 300 sheets. So every component was managed separately. There was better control in revision and management of the data. So as I said, we use bottom-up design strategy, manufacturing sequence replicated in Creo mechanical design. Bill of material was generated automatically from the models as reports. And now to cut down the cycle time, we do transformers and each transformer is customized for a customer. Each transformer is different. Now if we start doing from scratch, the design cycle time would stretch out. So what we did modular designs of different aspects of the transformer. Say, for example, a conservator, the tank, the cooling. So we did different modules driven by layouts, which is in notebooks now. So all the intelligence was put into the layouts, and the designer was just asked to key in the inputs, which was maybe 5 or 10, and then a base model was auto-generated, right? And then, we have a standard library of components, and then when we have the modular approach, and then when we got the basic model, then we use the standard library of components. We pick them from the library, and we use the pick and place technology. So we have a library, we have the base model, so we pick a component and place it on the model, and the component's placed. For example, if you want to put a handle on a tank, so on the plate, a cutout is required, then at a higher assembly level, the flange is required, and then at the next higher level, you have the cover. Now that was done at one stroke. You pick, a cutout is done, the welded flange is done, and the cover is placed at it. So all at one stroke. So that really cut down on cycle time. So we've used this pick and place technology to our advantage, and we are still, our library is still growing, and we're still working on improvements. Now this is a recent transformer that we've done. I just put a mannequin there to show in perspective how big the product is. So typically a transformer, say from a distribution to a power transformer, a distribution transformer might have 300 components, and a power transformer, big one, might have 3,000 components. So we have to handle all those components accurately, and we have to optimize the design. So Creo has helped us in doing that. We use simulation. I'll show you in a minute. We use simulation, we use CFD, all to optimize the design. That's another view of a 180 MVA transformer. In fact, this transformer is in manufacture right now. Now here, a cross-sectional view, we're showing the internals. There's the bushing and all the leads. So each and every component is managed by the designers, both electrical and mechanical. In fact, now we are implementing a PLM, project lifecycle management system, so that we've got separate people working for the internals, separate for the externals, so they can work collaboratively together and further cut down the cycle time. This is another view of a transformer which we did for Western Australia with the internals in there. And yeah. Now, this is the biggest transformer that we've done. It weighed almost in excess of 200 tons. And the dimension of this was about 10 meters long and 3 meters wide and about 4 meters high. So it's all metal, and we did, it has to have overpressure, and it has to sustain vacuum. So all that was done in Mechanica, and we optimized the tank. So this is basically what we did in Mechanica. And this is an exaggerated view of how the deflections were, so we could have an idea of how the forces were playing up. We use CFD. Now, obviously, we have a oil circuit, hot oil circuit, which has to be cooled. So we have to know, when the windings come there, how the flow is, whether there's any laminar flow or it is getting delaminated, and how the cooling happens. So we do this, and we design all our flow structure. This is another view of that. And also here, it's in terms of velocity streamline, so there's a lot of things happening here which needs to be corrected. Thank you. That is in a short what we had to do, and we're also using augmented reality in a big way, and I'll invite my colleague Victoria to take over. Thank you.
Not in a big wings though. So we just started to use the technology for our marketing purposes. So we are at the beginning of the journey, but we believe that using the technology will give a very great experience to our customers. So being a manufacturer of such a complex and very large piece of equipment, for us it's always a big challenge to display the product at trade shows, and as well to bring it to our customers. So it's a very big product, so it's not very easy to put in your suitcase and just check it with yourself. So to overcome these challenges, we decided to come up with augmented reality experiences. So we can bring the model of our transformer to the trade shows and show to everyone. So 2 months ago, we exhibited in Sydney at trade show, and you can see that video that a guy wearing like HoloLenses can see a model of our transformer, and we have 3 sizes, so it's a small, medium, or large. And you can walk around, you can go inside, you can see a different components of the transformer. So initially there were some people who were not really comfortable to wear this kind of very futuristic like piece of device. But I think curiosity took over, and by the end of the day we had a line of people who really wanted to see what is happening inside. So it works very well for us, and also we had a couple of customers who came to us and said, okay, let's do something together. It's such a cool idea, so let's see how we can create an experience together. So was very well received, and we were very happy. So then we decided to use iPads as well. So because not everyone is very comfortable, we said, okay, so we have a different tool, to access the experience, and using iPad, so you can see the picture here. You can also see the model transformer and do the same actions. You can go inside, you can walk around, etc. So last month we went to the Philippines, and for our company it's a very new country, so new market, people didn't know who we are, so what to do, etc. And on top of this one, people were not really comfortable to visit our stand and to talk to us because maybe of some cultural, like differences, etc. So we decided to run a competition. Okay, so what we did was we placed a red cap inside of our model. So, and we encourage people to come to our stand and take a transformer challenge. Okay, to navigate, through, like our product and find where the cap was. So, and it's actually drove so many people to our stand that, it was a really an icebreaker for us, to start a conversation with the customers. So I'm going to show you.
This one doesn't have a cap inside.
Yeah, it doesn't have a cap. So, so show the way it works. Okay, so here you can see a model of our transformer. So you can, as I said, you can walk around. I believe you can even open some of the stuff. So you can go inside. It's empty, but you have another model where you can actually can see all the internals, and you can switch off the externals, and you can see only internals because it's such a complicated device. So you can actually customize, like based on what you want to show. So yeah, it works very well for us. So and it's what we're doing at the moment. But we're also looking at some other ways to utilize augmented reality. So at the moment we are planning to create some training materials for our suppliers and for our own staff, and we have lots of students who visit our factory. So at the moment, so we are working on how we can actually create some kind of like model for the training purposes. Yeah, so that was our experience, and yeah, if you want to have a look, so I guess during the lunch break you can get access to our model and see a close look. Yeah, thank you.